Okay, welcome back, and now we're going to do the proof. From Theorem 1, we're going to prove that the derivative of sine is cosine. So let's start. So we're going to use the limit definition, right? So we're going to use limits and start with the derivative with respect to x of sine x is equal to the limit as h approaches 0 of our difference quotient, which is going to be sine of x plus h minus sine x over h. So now, at this point, what we're going to use is we're going to use the sum identity for sine. Okay, so we're going to expand out the numerator. Okay. Oh, let me write it over here. So that's going to equal the limit as h approaches 0 of. Okay, so this is going to end up being sine x cosine h plus cosine x sine h, and then of course minus sine x all over h. Okay, so there's one identity that you have to know. Okay, now we're going to regroup and split this up into two fractions. Okay, so what we're going to do is we're going to move the sign here, move this down, and then we'll split it up. Okay, because I've got the sine x here and the sine x here, we're going to want to factor that out. You'll see why in a moment. So let's do sine x cosine h minus sine x over h plus the limit as h approaches 0 of cosine x sine h. You know what, let me put these in parentheses because I don't want you getting confused with hyperbolic cosine and hyperbolic sine. And of course, this is over h. Okay? So now, we're going to factor out sine x and cosine x. Okay, so here we're going to factor out the sine x. And we're going to get cosine h minus 1 over h. And then we're going to get plus the limit as h approaches 0. Oops. Yeah. Of cosine times sine h over h. Okay? Now, the thing is since this is only in terms of x, this is only in terms of x, and the limit is in increments of h, we can pull the sine and the cosine out of the limit. Okay? So let's do that. Even though you probably see where this is going, but let's just take the extra step to pull that out. And so it becomes sine x times the limit as h approaches 0 of cosine h minus 1 over h plus cosine x times the limit as h approaches 0 of sine h, sine h over h. Okay? And so now, this realize that this cosine h minus 1 to h as h approaches 0, this is going to go to 0. Why? This is from something we shown before. Okay? And of course, this goes to 1. So guess what? Oops. This is going to equal sine x times 0 plus cosine x times 1, and we get cosine x. Okay? And that's the end of our proof. You have a great day.